Did you hear that? That is Neptune, or more accurately, signals associated with this distant world transformed into something we can hear. And somehow, the eerie sound fits perfectly, because Neptune may look like a calm blue world floating peacefully at the edge of the solar system, but almost everything about this planet is extreme. Neptune is the 8th and most distant major planet from the Sun, orbiting at an average distance of about 4.5 billion kilometers. From Earth, it appears as a tiny blue point, so distant that it cannot be seen with the naked eye. Even sunlight takes more than 4 hours to reach it. Out there, the Sun no longer looks like the enormous blazing disk we see from Earth. It appears much smaller, and Neptune receives only a tiny fraction of the sunlight our planet receives. You might expect a world this distant from the Sun to be almost completely frozen and motionless, a quiet planet where very little happens. But Neptune is anything but quiet. Beneath its beautiful blue appearance lies one of the most violent atmospheres ever discovered, with enormous storms, rapidly changing clouds, and winds faster than those measured anywhere else in the solar system. Neptune is enormous compared with Earth. It is roughly 4 times wider than our planet, and about 57 Earths could fit inside it by volume. But Neptune is not simply a larger version of Earth. It belongs to a class of planets called ice giants, along with Uranus. Its atmosphere consists primarily of hydrogen and helium, with methane and other compounds mixed in, while deeper inside lies a hot, dense mixture of materials such as water, methane, and ammonia under extraordinary pressures. And just like Jupiter and Saturn, Neptune has no ordinary solid surface where a spacecraft could simply land. What we call its surface is really the visible top of an atmosphere that becomes progressively denser as you descend. From space, however, none of that is obvious. Neptune looks almost peaceful. Its blue disk seems smoother and calmer than the chaotic bands of Jupiter. For decades, that beautiful blue color was one of Neptune's defining features. Methane in its atmosphere absorbs red wavelengths of sunlight and contributes to its blue-green appearance, although scientists have learned that Neptune's true visible color is probably less intensely blue than many famous processed images made it appear. Recent reprocessing of Voyager-era observations suggests Neptune and Uranus are actually more similar in color than the vivid, deep blue Neptune commonly shown in textbooks. The planet we thought we knew was, in a very literal sense, not quite the color many of us imagined. But color is the least surprising thing about Neptune. If you could somehow place a spacecraft into Neptune's upper atmosphere, the first major danger would be the wind. Neptune has the fastest planetary winds measured in the solar system. In some regions, winds can exceed 2,000 kilometers per hour. That is faster than the speed of sound in Earth's atmosphere, and several times faster than the winds inside the strongest hurricanes ever recorded on our planet. Imagine an Earth hurricane moving not at 200 or 300 kilometers per hour, but at more than 2,000. Now imagine that weather system stretching across an enormous planet with no continents or mountains to slow it down. This is the atmosphere of Neptune. And this creates one of the planet's greatest mysteries. Neptune is almost 30 times farther from the Sun than Earth. It receives very little solar energy compared with our planet, yet somehow, its atmosphere is extraordinarily active. Powerful jet streams race around the planet. Clouds form and disappear. Giant storms emerge, change shape, and sometimes vanish completely. On Earth, much of our weather is powered by sunlight heating the surface and atmosphere. But on Neptune, sunlight alone cannot explain everything we see. The planet radiates significantly more energy than it absorbs from the Sun, meaning that heat escaping from deep within Neptune is helping power its violent atmosphere. Somewhere beneath those blue clouds, Neptune is still releasing internal energy left from its formation, and perhaps other ongoing processes scientists continue to investigate. We first saw the true violence of Neptune in 1989. That year, NASA's Voyager 2 spacecraft became the first, and so far only, spacecraft to visit Neptune up close. After traveling for more than a decade through the outer solar system, Voyager 2 flew past this distant blue world and transformed our understanding of it. Scientists expected to find an extremely cold planet. What they did not necessarily expect was a planet covered in dynamic weather. Voyager photographed an enormous dark storm in Neptune's southern hemisphere. It became known as the Great Dark Spot. At first glance, it looked strangely familiar. Jupiter has the Great Red Spot, an enormous storm that has persisted for centuries. Neptune appeared to have its own version, a gigantic dark vortex roughly comparable in scale to Earth. Winds raced around it at extraordinary speeds, while bright white clouds formed nearby. These bright clouds were likely produced when air was forced upward, cooled, and condensed, somewhat analogous to certain cloud formations around mountains on Earth, except there are no mountains beneath Neptune's visible clouds. The Great Dark Spot immediately became one of Neptune's most recognizable features, but then something strange happened. It disappeared. When the Hubble Space Telescope observed Neptune several years after Voyager's encounter, the enormous storm was gone. Scientists had expected it to remain, perhaps like Jupiter's Great Red Spot, but Neptune's atmosphere had erased it. Then other dark vortices appeared in later observations. Some formed in different regions, some drifted across the planet, some weakened and vanished. Neptune's giant storms are not permanent landmarks. They are born, they move, and eventually, they die. This makes Neptune's atmosphere extraordinarily dynamic. A storm large enough to swallow much of Earth can appear, survive for years, and then disappear into the surrounding atmosphere as though it had never existed. And the deeper you travel into Neptune, the stranger the planet becomes. Imagine beginning a descent through those blue cloud tops. At first, there would be no moment when you suddenly land. There is no familiar crust beneath you. Instead, the atmosphere simply becomes thicker. Pressure increases continuously. Temperatures begin to rise as you descend, despite Neptune being one of the coldest planets in the solar system at its visible cloud tops. Hydrogen, helium, methane, and other gases around you become compressed into increasingly dense states of matter. The blue sky above would eventually disappear. Sunlight would fade. The pressure would climb far beyond anything found naturally at Earth's surface. Any ordinary spacecraft would eventually be destroyed, not necessarily in a dramatic explosion, but through a relentless combination of pressure, temperature, and atmospheric forces. Its structure would fail as the environment became increasingly extreme. And yet, even if you could build something indestructible and continue downward, Neptune would become even stranger. Deep beneath the atmosphere is thought to be a vast mantle rich in water, ammonia, methane, and other materials under tremendous pressure and temperature. Calling it an ocean, however, can be misleading. This is nothing like Earth's oceans. Under such extreme conditions, matter behaves in unfamiliar ways. Water and other compounds may exist in exotic high-pressure states that cannot naturally occur at Earth's surface. And within these depths may be one of Neptune's strangest possibilities: diamond rain. It sounds like science fiction, but laboratory experiments and theoretical models suggest that under the enormous pressures inside ice giants, such as Neptune, methane can break apart. Carbon atoms may then be compressed into diamond structures that sink deeper through the planet. Imagine diamonds forming thousands of kilometers beneath Neptune's clouds and falling slowly through an unimaginably hot, dense interior. But this is important. No spacecraft has directly watched diamonds raining inside Neptune. It remains a scientifically supported possibility based on experiments and models of conditions thought to exist within ice giants. Neptune's deep interior is still largely inaccessible to us, and much of what happens there must be reconstructed using physics, laboratory experiments, and measurements of the planet from afar. And then there is Neptune's magnetic field. On Earth, the magnetic field is roughly aligned with our planet's rotation and generated deep within the interior. Neptune's field is much stranger. Voyager 2 discovered that its magnetic field is strongly tilted relative to the planet's rotation axis, and significantly offset from the planet's center. The result is an oddly shaped magnetic environment that changes dramatically as Neptune rotates. This suggests that Neptune's magnetic field may be generated not in a compact metallic core like Earth's, but within electrically conducting fluid layers farther out in the planet's interior. Even Neptune's magnetic field refuses to behave normally. But perhaps the strangest thing about Neptune is how little we actually know. Voyager 2 flew past the planet only once. It did not enter orbit. It did not remain there for years like Cassini did at Saturn. It approached Neptune, collected an extraordinary amount of information, passed the planet, and continued outward toward interstellar space. That means many of the close-up images we have of Neptune came from a brief encounter that happened in 1989. Think about that. We have sent orbiters to Jupiter. We spent more than a decade studying Saturn with Cassini. Mars has been visited by orbiters, landers, and rovers. But Neptune, the planet with the fastest known winds in the solar system, disappearing dark storms, an unusual magnetic field, a mysterious deep interior, rings, and a fascinating collection of moons, has never had a dedicated orbiter. There is still an entire world waiting to be properly explored, and Neptune itself is only part of the story. Orbiting around it is Triton, one of the strangest moons in the solar system. Triton moves around Neptune in the opposite direction to the planet's rotation, a retrograde orbit that strongly suggests it did not form alongside Neptune. Scientists think Triton was probably a dwarf planet-like object from the outer solar system that was captured by Neptune's gravity long ago. That capture must have been violent. Bringing an object as large as Triton into orbit would have dramatically disrupted Neptune's original moon system. Existing moons may have collided, been thrown away, or reorganized into new orbits. Today, Triton remains a frozen witness to that ancient event. When Voyager 2 passed Triton, it discovered something astonishing: active geyser-like plumes erupting from its surface. Despite being one of the coldest known worlds, Triton was not completely inactive. Dark material was being blasted kilometers above its icy surface, likely driven by seasonal heating from the distant sun. A frozen moon at the edge of the solar system was still changing. Neptune also has rings, although they are nothing like Saturn's brilliant system. They are dark, faint, and difficult to see. Some contain unusual concentrations of material known as arcs, which puzzled scientists because orbital motion should normally spread the particles more evenly around the ring. The gravitational influence of nearby moons, particularly Galatea, is thought to help maintain these structures. Everything about Neptune seems to carry the same pattern. From far away, it looks simple. Get closer, and it becomes complicated. Its peaceful blue appearance hides supersonic winds. Its dark spots hide storms large enough to rival Earth. Its frozen distance from the sun hides a planet releasing powerful internal heat. Beneath its atmosphere may lie exotic forms of matter and perhaps diamonds forming under crushing pressure. Its magnetic field is strangely tilted and displaced. Its largest moon may be a captured world. Its faint rings behave in unusual ways. And even after all of these discoveries, we have only visited Neptune once. There is another fact that makes Neptune feel especially distant. A single year there lasts about 165 Earth years. Neptune was discovered in 1846, meaning it completed its first full orbit around the Sun since its discovery only in 2011. Human civilization has known Neptune exists for less than 2 Neptunian years. Its seasons themselves last for decades. While entire generations are born, grow old, and die on Earth, Neptune moves through only part of a single orbit. And out there, nearly 4.5 billion kilometers from the Sun, the winds continue. Storms form in darkness. Clouds race around the planet faster than any hurricane on Earth. Dark vortices appear and disappear. Deep below, unimaginable pressure transforms matter into forms we can barely reproduce in laboratories. And Triton continues its strange backward orbit around a planet that may have captured it billions of years ago. Neptune is not terrifying because it is evil or because it is waiting to destroy something. It is terrifying because it shows us just how extreme nature can become. There are no monsters there, no hidden civilizations, no giant creatures beneath the clouds. There doesn't need to be. The planet itself is enough. A world without solid ground, where winds can exceed 2,000 kilometers per hour, where Earth-sized storms can appear and vanish, where the atmosphere eventually gives way to crushing high-pressure interiors. and where almost everything we know comes from one spacecraft that raced past more than 3 decades ago. From Earth, Neptune is just a tiny blue dot, quiet, distant, beautiful. But if you could somehow travel those billions of kilometers and see it up close, that peaceful blue world would disappear. You would find a planet alive with motion, a planet powered partly by heat escaping from within, a planet with the fastest winds in the solar system, a planet whose greatest mysteries are still hidden beneath thousands of kilometers of atmosphere. And perhaps the most unsettling thing about Neptune isn't what we've discovered. It's how much we still haven't seen. If you thought Neptune was terrifying, you haven't seen Saturn yet. The most beautiful planet in our solar system hides one of the strangest and most violent worlds we've ever discovered. Its storms never seem to end. It has a giant hexagon at its north pole, and if you tried to land there, you'd never find the ground. Click the video on your screen and discover why Saturn is far more terrifying than it looks. And if you enjoy exploring the darkest mysteries of space, subscribe, because we're just getting started.